Hello everyone, welcome to mentorbuddy.com. This is your mentor Gurvansh, and now we are going to learn how do we actually perform KNN using Python programming language. So as usual guys, in this starting we are going to start by importing the library. So here I am writing the library name. As you all know, this is import numpy as np, import pandas as pd, import matplotlib dot pyplot as plt. After we run this, we are going to import our dataset. Now guys, the dataset for our KNN algorithm is the same dataset which we used in the SVM algorithm. The reason for choosing the same dataset was so that you guys can compare the output of the KNN algorithm and the SVM algorithm, that what is the difference or how much accuracy we are getting. So here I am going to import the dataset. df is equal to pd.read underscore csv. Here we write the name of the dataset was classification.csv. Then I'm going to print my data frame. So it is exactly the same data frame, so you all already know about it. Let me explain it again. So we have the age column, estimated salary column, and the purchase column. The problem statement says that you have to determine whether the person or whether a new person will purchase your product or not. Right now we are going to start by extracting x and y from the data frame. Now guys, as you guys can see here, age and estimated salary have different scales, so we'll have to perform feature scaling on it. So here I'm going to write, first of all I'm going to extract my x and y. So x is equal to df.iloc all the rows comma all the columns till -1 dot values. Then we have y is equal to df.iloc all the rows comma only -1 column dot values. Then we will run this cell. Once we run this cell, our x and y extraction is done. With this I will first perform feature scaling on it. So feature scaling here. For this we need from sklearn dot preprocessing import standard scaler. Then we have sc is equal to standard scaler class. The functions are already defined. Then we write x is equal to sc dot fit transform x. So with this our feature scaling is done. Once the feature scaling is done, we are going to divide our data set into test and training data. So dividing the x and y into training and test set. So here I'm going to write from sklearn dot model selection import train test split. So here I'm going to write xtr comma ytr comma xtr comma xtest comma ytr comma yte is equal to train test split x comma y comma test size is equal to 0.2 comma random state is equal to 0. So with this our splitting will be done. Train test splitting will be done. So let's run this now guys. Once we are done with the splitting, as usual we are going to import our algorithm. So importing and training the KNN classification model. Then we write from sklearn dot neighbors. So the module name this time is neighbors. Import k nearest classifier. So here we have k nearest classifier. Then I'm going to First of all, I'm going to import this by pressing shift enter, then I will show you what are the different values you can give. So here I'm again going to write the name as classifier is equal to k nearest neighbors, then I'm pressing shift tab to get to know. Now here guys, we give the n neighbors value to tell how many neighbors we are looking for, then we give the matrix value. Now let's take a look at the metric. Now if you remember in the theory part, in the intuition part, I told you that the metric, the distance which we can use is a Euclidean distance or a Manhattan distance to calculate the distance between the nearest neighbors. So for this, for metrics we use the Minkowski metric, and then this Minkowski we have to provide any two values for p. Now p determines which distance are we going to use. P is equal to 1 is Manhattan distance and p is equal to 2 is Euclidean distance. So here my first is n neighbors. So my first parameter n neighbors, let's put 7. Okay, then we have the metric parameter. So in the metric parameter we write Minkowski. Then we write p is equal to 2. So p is equal to 2 means Euclidean distance. Then we write over here classifier dot fit with xtr comma ytr. Once it is done, we are going to run it again and our k neighbors classifier will be trained. So as usual, here I am going to predict the output using the test data and getting the accuracy score and confusion matrix. So here I am going to write ypred is equal to classifier dot predict using xtest. Then we are going to, okay, let me write the libraries first. From sklearn dot metrics import accuracy score comma confusion matrix. Here I am going to create the variable for accuracy score is equal to accuracy score between my ytest and ypred, then confusion matrix between my again ytest and ypred. So confusion matrix between my ytest and ypred. So let's run it. Okay, let me first print the accuracy score. So when you print this time the accuracy score is 95%. Last time with SVM it was 91%. So here we can say for our this particular model, the KNN is this particular data set, our KNN model is working better. So let's visualize. Okay, so here we are plotting the confusion matrix and visualizing the test data output. So here we need from ml extend dot plotting import plot confusion matrix comma plot decision regions. Then here I am going to write plot confusion matrix between the plot confusion matrix using the CM variable, and then I'm going to write plt.show. Let's run it. It will give the output that out of 58 zero values, 55 were predicted correct, 3 were predicted as 1 which is wrong. Out of 21 one value, only 1 was predicted wrong and 21 were predicted correct. So here I'm going to write again plot decision regions using x value which is xtest xte comma y value which is yte comma classifier is the classifier object which we created. Then again we are going to write plt dot show. So here with this, once it is computed, it will show us how does the output of KNN looks like, or what is the classifier we will get. Now keep this in mind, in the SVM we use the linear classifier, so the line drawn was a linear line. Here we have a non-linear classifier, so the line is curved. But if we look carefully, the output of this is much better as compared to our SVM algorithm. It is 95% accuracy. Now here guys, as you guys can see, 3 0 values were predicted as 1, so 3 squares are in the 1 area, and 2 values only, sorry, 1 value was predicted as 0, one value was predicted as 0, which is in this area. The triangle is over here. So guys, this was all about KNN programming or KNN model training of ML using the Python programming language. I hope that you guys understood what we did and how we did it. So guys, thank you for joining us on mentorbuddy.com. Bye bye, take care.